Okay, I'm doing number 25 in chapter 8. It says, an 8-meter, 200 Newton uniform ladder rests against a smooth wall. The coefficient of static friction between the ladder and the ground is 0.6, and the ladder makes a 50-degree angle with the ground. How far up the ladder can an 800 Newton person climb before the ladder begins to slip? So I'm going to draw, this is the wall, and the ladder, and this is 50 degrees, and there's a person on this ladder, and we know that the whole ladder is 8 meters, and we don't know how far up the person is, so we'll say x meters. And we know the ladder weighs 200 newtons, and the person is 800 newtons. And, alright, so there's a weight going down of the person and the ladder. There's friction going that way, and friction equals normal times the coefficient of static friction. There's a normal going up right here because the ladder is pushing down, and there's another normal over here because the ladder is pushing that way, and we'll do a lowercase n for that one to differentiate between these two normals. This is positive x, and this is positive y. Alright, so the first thing I'll do is a sum of forces in the x direction. So there's this normal going that way, and that's positive, minus this friction, which is going that way, which is n, and that equals 0, because the ladder isn't moving in the x direction. Now I'll do sum of forces in the y. There's normal going up, which is positive, minus the weight going down. And we know the weight is the ladder and the person, so that's, add those up, it's 1,000 newtons. And because this equals 0, we know the normal is also 1,000 newtons. Okay, then we can use this to solve for this, because we know it was given in the question. The coefficient of static friction is 0.6. So if we just plug that in, sorry, 0.6 equals 0, therefore n, this normal, is 600 newtons. Okay, the last equation that I'm doing is for torque. And I'm going to make the axis right here, and the axis is going to look like this. And I'm doing it like that. I'm not making it like this because I want to measure the length of the ladder, and it's easier to do it this way. So I'm going to make this angle 50 degrees in the axis. Here, I'll make it bigger. This. No.
What?
So this is the ground. This will be a 50-degree angle, and this will be the length of the ladder. So if it starts here, the end of the ladder will be 8 meters, which is r, and r of sine theta. The force is this normal force. We made it 600. And the angle here is 50 degrees because of that angle. Okay, the next force I'm doing is in the middle of the ladder. So it'll be 4 because it's 8 divided by 2. The ladder is 200 newtons. And it's 40 degrees, because if this is 50, we're making this a triangle. If this is 50, this is 90, this has to be 40. The last one is x meters, because we don't know how far the person is. they weigh 800 newtons, and that angle is also 40 degrees. And the overall torque is 0 because it's not moving. So put these two together, put this on the other side, we come out with 3,162.78 equals this, 800x sine 40, and x equals 6.15 meters. That's it.